Imagine a world not ruled by brute strength, but by calculation.
We often picture dinosaurs as lumbering giants, consuming everything in their path with mindless hunger. Or as armored tanks, reacting on pure instinct. We think of the Tyrannosaurus rex, the Triceratops, the colossal sauropods. But in the shadows of the Late Cretaceous, something else was watching. Something different. It didn't rely on bone-crushing jaws or impenetrable armor. It relied on something far more dangerous, a mind that was beginning to understand the world around it. This was the Troodon.
For decades, paleontologists have stared at the fossilized remains of this creature, puzzled by a skull that broke all the rules. In proportion to its body size, its brain was immense.
It possessed the largest brain-to-body ratio of any dinosaur known to science.
This simple fact has sparked one of the most controversial and fascinating debates in the history of paleontology. Just how smart was this animal?
Could it solve problems? Did it communicate in complex ways?
And perhaps the most haunting question of all, if the asteroid had missed the Earth 66 million years ago,
Would this creature have continued to evolve?
would it have walked a path similar to ours?
Today, we are going to dissect the mind of the smartest dinosaur that ever lived.
We will strip away the Hollywood myths and look at the hard biological evidence.
We are going to look into the large, golden eyes of the Troodon and ask,
To understand the intelligence of the Troodon, we must first understand the machine that housed it.
this was not a large animal.
Standing about waist-high to a human adult and stretching roughly 2.5 meters in length. It was built for agility, not power.
But its physical construction hints at a sophisticated nervous system. Look at the eyes. They are enormous, facing forward, providing overlapping fields of view. This is binocular vision, the hallmark of an advanced predator.
It grants depth perception, the ability to judge distance with pinpoint accuracy.
But more importantly, the size of the orbits suggests it was nocturnal.
While the giants slept, the Troodon owned the night.
Processing visual information in low light requires significant brain power.
You need to interpret shadows, movement, and depth instantly. This sensory input fed directly into a brain that was already working overtime.
Then there are the hands.
Unlike the useless forelimbs of the T-Rex, the Troodon possessed long, grasping fingers.
Some studies suggest they had a degree of opposability, allowing them to manipulate objects.
A creature that can manipulate its environment is a creature that is compelled to understand it.
If you can pick up a rock, you might eventually learn to use it.
And let's not forget the weapons.
On its foot, a retractable sickle claw, similar to the velociraptor, but smaller and more precise.
This wasn't just a slasher, it was a precision instrument.
To use such a weapon effectively requires coordination, timing, and strategy.
But let's talk about the brain itself.
Scientists use a measurement called the encephalization quotient, or EQ.
It's a way to estimate potential intelligence by comparing brain size to body size.
Adjusting for the fact that bigger animals naturally have bigger brains to control their massive bodies.
A crocodile has an EQ of roughly 1.0.
A T-Rex, surprisingly, sits around 2.0 to 2.4, smarter than we give it credit for.
But the Troodon? The Troodon pushes the scale to nearly 6.0.
This places it in the same realm as modern birds like the ostrich, and even some mammals like the opossum.
While that is still far below the human EQ of 7.5, it is a staggering leap for a dinosaur.
It implies a level of cognitive function that goes beyond simple instinct.
It suggests memory. It suggests learning.
It suggests that the Troodon could remember where prey was most likely to be at certain times of the year.
It implies they could remember the outcome of past encounters. If a hunting tactic failed, they wouldn't just repeat it mindlessly. They would adapt. This adaptability is the spark of true intelligence.
High intelligence rarely evolves in isolation.
In the animal kingdom, big brains are almost always linked to social complexity.
Think of wolves, dolphins, chimps, and humans.
We got smart because we had to navigate the politics of the pack. Did Troodon live in packs?
The fossil record is fragmented, but the evidence is compelling.
Mimicking the sounds of the forest.
One distracts the prey, maybe a Thescelosaurus, while the others flank it from the shadows.
This level of cooperation requires a theory of mind.
You have to understand that your packmate has a job to do, and you have to trust them to do it.
You have to anticipate the reaction of your prey.
This is high-level cognitive processing. This is thinking.
Furthermore, we must consider their parenting.
The closely related dinosaurs of the Maniraptoran group were diligent parents.
They sat on their eggs. They protected their young. A longer childhood means more time to learn.
If young Troodons stayed with their parents, they were being taught.
Knowledge was being passed down from one generation to the next. This is the foundation of culture. He extrapolated the evolutionary trajectory of the Troodon.
He noted that its brain was growing larger over millions of years.
He asked, what if that trend continued?
Its fingers became more human-like for tool use.
It looked, essentially, like a reptilian alien. While modern science largely rejects the humanoid shape of the Dinosauroid,
Evolution doesn't necessarily aim for the human form. The core concept remains valid. It was the vanguard of a new kind of life on Earth. Intelligent life.
Maybe they were using stones to crack open hard-shelled eggs.
Maybe they were using sticks to extract insects from rotting logs. They were likely solving problems we can't even imagine.
but the universe is indifferent to potential.
66 million years ago, a rock the size of a mountain slammed into the Yucatan Peninsula. The resulting cataclysm didn't care about EQ scores.
It didn't care about binocular vision or cooperative hunting.
The sky turned black. The food chains collapsed.
The intelligent, high-metabolism Troodon, which required constant fuel for its large brain, starved just as quickly as the dim-witted giants.
Was the Troodon smarter than a human? No.
In raw processing power, abstract thought, and technological capability, we are unique.
But that is the wrong comparison to make.
The Troodon was the smartest thing nature had produced on land up to that point.
It was a glimpse of what was possible.
It was a creature that had moved beyond simple survival. And had begun to interact with its world with intention.
We see a different path that intelligence could have taken.
A path where feathers, scales, and claws accompanied the dawn of consciousness.
In the end, the Troodon reminds us that intelligence is not a destination, but a journey.
And for a few million years, in the dark forests of the Cretaceous,
the journey was well underway.